All right, guys. Good evening, everyone, and welcome to today's tutorial. All right. Um, we're going to look at differential. We're going to look at differentiation rather, not differential equation. So differentiation, which is the origin of calculus. So how to differentiate a function. So given that y is equals to x, so how do we find it? So, and all of these things is their calculus, okay? So differentiation, okay? So that's what we'll be looking at today. Excuse me. Okay, so let's start. But what we are going to be doing is we are going to be using first principle. That's what we are going to be using first principle. That's what we are going to be using. So differentiation using first principle. All right. Now, if y is equals to x, and you have to differentiate with respect to x. You have to differentiate y with respect to x, and y is equals to x. How do you do this? Using first principle. How do you go about it? First thing is that in place of y, you're going to put y plus change in y. That's what you put. And in place of x, you put what? X plus change in x. So it's as easy as that. Once you have y, you put y plus change in y. And once you have x, you put x plus change in x. So it's as simple as that. So now here we are given a function y is equals to x. What do we do? All right, we start with, in place of this y, we put y plus change in y, which is equals to x. That's x plus change in x. Very easy. X plus change in x. Okay. Now, after we have done that, the first thing we do is that the next thing we are going to do is that we are going to make sure that we collect like times or rearrange so that we are going to be left with dy dx. So we have dy dx will be equals to plus x plus change in x minus y. Okay, then change in y will be equal to x plus change in x minus, what is y? Y is what? Y is equals to x. So you put x here. And then changing y will be equals to x minus x plus changing x. All right. Then we have that changing y is equals to x minus x is 0. Then you'll be left with changing x. So the next thing you do is you divide through by changing x. So if you divide through by changing x, we have that changing y is equals to changing x divided by changing x divided by changing x. All right. So after we have done this, we have that changing y divided by changing x is equals to 1. Then at this point, we are going to find the limits. We take the limits. We say taking the limit. So taking the limit of both sides. Then as changing x approach 0. Okay, that's what we are going to do. Then if you take the limit, it's going to be the limit of changing y over changing x as changing x approaches 0, which is equals to the limit of 1 as changing x approaches 0. So if you take the limit of changing y over changing x, that's going to give you dy dx, which is equals to, if you take the limit of 1, you can't take the limit of 1, so which is going to give you 1. Okay, so that is your answer. That is differentiation using first principle. So which means that if y is equals to x, then dy dx is equals to 1. So once you differentiate x, you have 1. All right, let's take another example. Now let's say that you have y is equals to x squared, for example. So if this is what you have, y is equals to x squared. Now I told you that in place of y, you are going to put y, you are going to put y, you will put y plus change in y, and in place of x, you put what? X plus change in x. Now, so here, we are going to put y plus change in y, which is equals to x plus change in x. So don't forget that the x is squared, so definitely this is going to be squared too. Then we have y plus change in y, which is equals to, once you expand this, it's going to be x plus change in x into x plus change in x, then which will give us x times x, that's x squared, x times change in x, that's going to be x change in x, then change in x times x, that's going to be x change in x, and change in x times change in x, that's going to be change in x all squared. Then we'll have that y plus change in y is equals to x squared plus 2x change in x, then plus change in x squared. Okay, then at this point we can collect the like terms. So we are going to have change in y will be equals to x squared plus 2x change in x, then plus change in x squared minus y. Okay, this is plus y, it becomes minus. All right, so we have change in y will be equals to x squared plus 2x change in x plus change in x squared minus, what is y? Y is from here. Y is what? Y is definitely, you can see this is y is x squared. So we'll put that. So we have x squared. So you rearrange, change in y will be equals to x squared minus x squared plus 2x change in x plus change in x squared. So this, we remove this, making it 0. Then change in y will be equals to 2x change in x, then plus change in x squared. So you notice something here, that change in x is common, so you can factorize change in x into 2x plus change in x, isn't it? So at this point, you can divide both sides by change in x, both sides by change in x. So this will remove this. So you have change in y divided by change in x is equals to 2x plus change in x. At this point, you take the limit. So taking the limit of both sides. So if you take the limit of both sides, you have that the limit of change in y by change in x as change in x approaches 0 is equals to the limit of 2x as change in x approaches 0, then plus the limit of change in x as change in x approaches 0. Then if you take the limit of this one, it's going to give you the y, the x, and then the limit of this is going to give you 2x. Then the limit of this, you put 0 here, so it's going to be 0, then which is what? 2x. So therefore, we'll say that dy dx is equals to 2x. It's as simple as that. Okay, let's take another example. Let's say that we have y is equals to x squared plus 3x plus 2. So we have to differentiate this using first principle. Okay, if you are differentiating this using first principle, you already know that y, we put y as y plus change in y, and x as what? X plus change in x. So let's do this. We are going to have y plus change in y, which is equals to x plus change in x squared, then plus 3 into x plus change in x, then plus 2. Y plus change in y will be equal to, I already told you how to do this, so but let's do it once again. X plus change in x into x plus change in x, since it's 2, okay, then plus 3x plus change in x plus 2. Then we have y plus change in y, which is equal to, so this will multiply this, is going to give you x squared. This will also multiply this, that's going to give you x change in x. This will multiply this, is going to give you x change in x, and this will also multiply this, which is going to be change in x squared, then plus 3x plus 3d 3 change in x plus 2 y plus change in y is equals to x squared plus 2x change in x plus change in x squared plus 3x plus 3 change in x plus 2. Okay, so don't forget that. Okay, don't forget that y is equals to x squared plus 3x plus 2. Don't forget. So from here, we can see that changing y will collect the like terms. So the next thing, once you have something like the next, you collect the like terms. You have x squared plus 2x changing x plus changing x squared plus 3x, then plus 3 changing x plus 2 minus y. Change in y will be equals to x squared plus 2x change in x plus change in x squared plus 3x plus 3 change in x plus 2 minus y is what? X squared plus 3x plus 2. Then you have change in y will be equals to x squared plus 2x change in x plus change in x squared plus 3x plus 3 change in x plus 2. You open the bracket using the minus, minus x squared minus 3x minus 2. Collect the like time. So you discover this one will remove this one, then this one will remove this one, and this one will remove this one. You'll be left with change in y will be equal to 2x change in x plus change in x squared plus 3 change in x. That's all. That's all. So we will factorize. If you factorize change in x, you are going to be left with 2x plus change in x plus 3. Okay, then divide both side by change in x, divide both side by change in x. So this, we cancel this, then you have 2x plus change in x plus 3. So at this point you take the limit. So taking the limit of both sides as change in x approaches 0, then you have the limit of change in y over change in x as change in x approaches 0 is equals to the limit of 2x change in x approaches 0 plus the limit of change in x as change in x approaches 0 plus the limit of 3 as change in x approaches 0. Therefore, you have the limit of change in y over change in x. Oh, sorry. Then once you take the limit, this will give you the y dx, which is equal to, if you take the limit of this one, it's going to be 2x. If you take the limit of this one, it's going to be 0, because if you put 0 here, it becomes 0. So you have 0. Then if you take the limit of a 3 is a constant, then it's going to be that constant. Then it's going to be 2x plus 3. So this is your answer. Which means that when you have y equals to 2x, when you have y equals to x squared, rather, not 2x. plus 3x plus what's that value? Plus 2. Okay, so plus 2 plus 2. It means that this will be your answer. So if you differentiate this will be your answer. 2x plus 3 will be your answer. Okay, let's take it a step further. Let's do something, something crazy. Let's say we have y equals to 1 over x. So 1 over x, let's do this. All right, okay, let's do this. Now we have y equals to 1 over x, and we have to find it. We have to differentiate this using first principle. So I told you that when you see y, you put y plus change in y, and where you see x, you put x plus change in x. All right. Then y is going to be y plus change in y, which is equals to 1 over x plus change in x. Okay. So we don't really need to do much here. So for the next thing we'll do is that we just collect the like times. We have change in y will be equals to 1 over x plus change in x minus y. Okay, then which is going to be 1 over x plus change in x minus what is y? Y is 1 over x. Then what do you have? You collect the like times. Let's find the LCM rather, not collect like times. Let's find the LCM. So we find the LCM is going to be x into x plus change in x, right? So this one divided by this one, you are going to have x minus this one divided by this one, you're going to have x plus change in x, right? Okay, so let's go for that. We have that dx will be equals to x minus change in x. This is what you have. By the time you open that bracket, divided by x into x plus change in x. So this and this will become 0. Then you have this, will remove this as 0. Then it's going to be minus change in x, then over x plus x change in x. So the next thing you do is that you divide both sides. So we're going to have the change in y over change in x is equals to minus change in x over x into x plus change in x, then divided by change in x, right? Since we are dividing by, so you can make it look like this can be 1 over change in x, then into minus change in x divided by x into x plus change in x, right? Then this we remove this, then you have 1 here. Then we have change in y over change in x is equals to minus 1 over x into x plus change in x. Okay, at this point, we'll just take the limit. So taking the limit, if you take the limit of both sides as change in x approaches 0, let's take the limit is going to be the limit as change in y over change in x approaches 0, then which is equals to minus 1, the limit, let's put it there. We're going to have the limit of minus 1 as x into x plus this change in x as change in x approaches 0. So what you simply do that, where you see change in x, you put 0. Then this will give you dy dx, which is equals to, you're going to have minus 1 over, that is x into x plus 0. Okay, so you have minus 1 over x times x is x squared. So which is what? Minus 1 over x squared. So easy. That is how to find, that is that. Okay, now let's now go to general principle. We have the general principle. Okay, this general principle is like anytime you are given something to differentiate. So this is just like something you'll be using to differentiate. So you don't need to be doing all of this stress. You don't need to be doing all of this stress. You just go straight to it. Okay. If you are given y equals to x raised to the power of n, where n is an integer, n is an integer, okay? Whether it can be positive integer, it can be negative integer, whatever integer it is. So y equals this, and you have to differentiate this using first principle. So we are going to get a formula. So, and that formula is what we are going to be using to do whatever we want to do. So we'll not be going through all these long processes again. We'll just be doing it directly. All right, let's get into it. If you have y equals to x raised to the power of n, I told you that you put y as y plus change in y, and x as what? As x plus change in x. Okay, so here you have y plus change in y, which is equals to, that's x plus changing x, then going to raise to the power of n. So at this point, there's something we can use. We can use normal expansion here. So we are going to use binomial. So we use binomial to solve this. So binomial will do well here. Binomial theorem will work well here. And this is how it works. You have y plus change in y. So it's very simple. We have we have two things here, entities here. We have x and change in x. So what will happen here is that x will decrease and change in x will increase. Like this x will first take the power of n. Whatever the n might be 2, it might be 4, it might be 5. So this x will always start with the power of the n, like the power, that's the integer. So if the integer is 5, that means it's going to be x raised to the power of 5. It will start like that. Then it will keep reducing. It will reduce from 5 to 4 to 3 to 2 to 1 to 0. And this one will start from 0. It will increase to 1, 2, 3 to then to this 5. And again, that's if n is 5. That's what we are going to do. So we'll start x raised to the power of n. Then because change in x is 0, so it's going to give us 1. So let me just put it so for clarity's sake, raised to the power of 0, because it's going to give you 1. Then plus this n will multiply the coefficient of x here, which is 1. So it's going to be nx. You subtract 1 from the power, so it will be reducing. So it's going to be n minus 1. Then you have change in x raised to the power of 1 over 1 factorial. Then plus, I'll just do 2. Then the next one is going to be n into n minus 1, close the bracket, because this will multiply this one. Then x raised to the power of n minus, if you subtract 1 from this, it's going to be minus 2, then into change in x squared over 2 factorial. So it's going to be continuous like that. So let's say this means it's continuous, then plus, we now have finally, just know that finally, at the end of the day, I said this x is going to reduce to, the power is going to be 0, right? So making it what? Making it 1, and this will finally take the power of n. So it's going to be changing x raised to the power of n. That would be our final solution. Then let's continue. Then we are going to have y plus change in y, which will be equals to, this is going to be x raised to the power of n, because this will give you 1. Then plus x n, not xn, nx is going to be nx raised to the power of n minus 1, change in x, right? Then divided by, you don't need to divide it because 1 factorial is still 1. Then plus, let me just write it 1. Then this is going to be n into n minus 1, x raised to the power of n minus 2. Then change in x raised to the power of 2. Then divided by 2 times 1, because 2 factorial means 2 times 1. So 2 times 1, which will give you 2. Then plus dot, continuous like that. Then plus change in x raised to the power of n. Okay, then we have y plus change in y, which is going to be x raised to the power of n, then plus n into x raised to the power of n minus 1. Okay, we are running out of time. Okay, I need to be fast. Then we have change in x, right? Then plus, we don't need to write the over 1 again. You already know. So n into n minus 1, x to the power of n minus 2, then change in x all squared. This is minus, then divided by 2, then plus, constants like that, then change in x to the power of n. Okay, so at this point, we collect the like terms. So this y will move here. You already know if it moves here, it becomes xn. So it's going to be minus. So it's going to be xn minus xn, then xn, then plus nxn minus 1, then change in x, then plus n into n minus 1. Okay, x n minus 2, then changing x raised to the power of 2 over 2, then plus continuously like that, we have n. All right, so this will give us 0. We have a change in y will be equals to n nx n raised to the power of minus 1 dx, sorry, not dx, changing x rather, changing x, right? Then plus this. Let's just factorize. We'll factorize now. We'll factorize now. So if you factorize, we are going to have that changing y will be equal to changing x, then into n x n minus 1, changing x, that's what you have, then plus n into n minus 1, n x raised to the power of x raised to the power of n minus 2, then changing x whole squared over 2, then plus this. No, sorry, it's not going to be over 2 again because we have removed 1 from it. We have factorized it. Okay, then plus. So this is, if you remove 1 from this one, is going to be that changing x and minus 1. That's what you have here. Yes, you have removed 1 from the factorize. So let's divide by changing x, and also divide this one also by changing x. So this, we remove this, right? Okay, so at this point, we will take the limit. We'll take the limit, changing y over changing x will be equals to nx n minus 1. Change, let's see, something is wrong here. Oh, sorry. Since we have factorized, this will no longer be here. We have factorized, it will no longer be here. Yeah. Then we have plus, we have n into n minus 1, x n minus 2, then changing x over 2, then plus then plus changing x raised to the power of n minus 1. All right, so we take the limit. So taking the limit of both sides. So let's take the limit. We take the limit of this one as changing x approaches 0. So we'll just take the limit of everything here together. So take the limit of this together. So n into x n minus 1, then plus n into n minus 1 multiplied by x raised to the power of n minus 2, then changing x, and then plus continuously like that, then till you have changing x raised to the power of n minus 1. So of course, everything here will become 0, everything here will become 0, everything like that continuously will become 0. Therefore, that's when you take the limit. Therefore, if you take the limit of this one, is always the y dx, which is equals to this one. You don't have to take the limit because there's no change in x here. So which is going to remain n x raised to the power of n minus 1. So that means that if you are given y equals to x raised to the power of n, then the differentiation of this is what is equals to this. So that will be all for today. Thank you so much for joining us. Make sure you like the video, make sure you share it, and in case you have any question, do comment it in the comment section. And thank you so much, and don't forget to subscribe. Thank you.